In the previous session, we saw the topic on the Cartesian system of coordinates, the coordinates system of coordinates, rectangular coordinates of the Cartesian system. So in this chapter, the chapter 14 of straight lines and systems of equations, system of equations, we are going to see the equations of straight lines for the NIOS Senior Secondary 11th and 12th grades mathematics. Let us see what are the subtopics covered in this video. So in this session, we are going to see the major subtopics as introduction to straight lines parallel to an axis, various forms of equations of straight lines, general form of the equation of a straight line, and also the angle between two lines. After forming the two lines, intersecting lines, a system of equations consists of a system of two linear equations that we will also see in this topic. General form of the equation of a straight line. Distance of a given point from a given line is the perpendicular distance from a given point to a given line. And we are also going to see parallel and perpendicular lines, the equations of parallel and perpendicular lines. Let's dive into the subtopics. First of all, let us see the introduction to straight lines. You see this image here, a picture of a girl wearing some ornaments and so on. Can you figure out how many points are in this figure? Infinitely many. This is what exactly a straight line. This is a plane, and each point is called a pixel, a picture element in an image. So we see that all these points have merged together and form a wonderful image. Similarly, a straight line consists of infinite number of points. When these number of points merge together, very close together, they form a straight line. So a straight line has infinite number of points. So this is what we are going to see, and we are going to see what is the equation of a straight line. Let us dive into the various forms of the equations of straight lines. First of all, we are going to see point slope form, the 2-point form, the intercepts form, and the normal or perpendicular form of the equation. We are going to see these things in detail now. Let us move on to the first form. Before that, let us see what are the equations of straight lines parallel to and perpendicular to the axis. Now we see here straight lines which are parallel to an axis given by the parallel equation of a straight line parallel to the x-axis is given by the equation y is equal to b, where b is a constant, as a fixed number of units, may refer to centimeters or some units, and it maintains a constant distance from the x-axis, either on the positive direction of the y-axis or into the negative, above or below. But it is parallel to the x-axis. So y is equal to b. This is of the form y is equal to b. B can be positive, 0. It can also be 0. If it is equal to 0, it will pass through the x-axis itself. So greater than 0, it lies above the x-axis. And if it is less than 0, it lies below the x-axis, just the negative side, the y-axis. Below the x-axis, you know that it's negative y-axis. Now, this is the equation of line parallel to the x-axis. Now, let us see line parallel to the y-axis. Parallel to the y-axis is the form x is equal to c. C is an absolute value. It's some distance from the y-axis because it maintains a constant distance from the y-axis on either side, of course, of the x-axis. This side or that side. Positive side, right of the y-axis is the positive side of positive x-axis. So x is equal to 3, for example, plus 3. 3 is to the right of the y-axis and it is parallel to the y-axis. Maintains a constant distance of 3 from the y-axis. And it's a vertical line. You can say it's a vertical line. Less than 0, if c is negative, then it will come to the left side. That is, it's a negative side of the x-axis. And it is left of the y-axis. And it is also maintaining the same distance from the y-axis because it's parallel to the y-axis. If c is equal to 0, then the line passes through the y-axis itself. It is nothing but the equation of the y-axis itself. The equation of the y-axis is hence x is equal to 0. And the equation of the x-axis is y equal to 0. That's all. This is a very important introduction. We move on to the other forms of the equations. The forms of the equations of a straight line. The equation of straight line has various standard forms. We will see that. Slope and intercept form. The slope and intercept form is the famous form y is equal to mx plus c. This is called the slope intercept form. Y is equal to mx plus c. Where m is given, if m is the slope, as we have seen in the previous session, in the system of coordinates, we have seen the slope of a line joining 2 points. It is tan theta. The theta is the angle made by the line with the positive direction of the x-axis. Already we have seen this. And is denoted by the small letter m. Hence, we have y is equal to mx plus c. And what is c? It is nothing but the intercept the line makes with the y-axis. It's a y-intercept. We can also call it as a y-intercept. So the y-intercept is the point at which the line intersects the y-axis. And it is the coordinates of that point will be 0, c. That's all. It's just 0, c. It will be on the y-axis itself, where the x coordinate is 0. Other concepts we have already seen in the previous session, the system of coordinates, Cartesian system of coordinates, rectangular coordinates. So that is already we have seen. So based on that, we will proceed further to the equations of straight line. So this is the first thing. This is also known as slope intercept form. Y is equal to mx plus c. Move on to the next. Here are some conditions, special cases where c equal to 0 means the line passes through the origin. And its equation is y is of the form y equal to mx. C is 0, m is 0, all are 0 means y is equal to 0, where it is the x-axis itself. Means again y equal to c, we get the same as the equation parallel to the x-axis. We now move on to the next form, which is called the point slope form. The point slope form has this form. You are given one point on the straight line, on the line, and its slope, the theta, the tan theta. It's denoted by small m. Is equal to, now we can say that if you take any point if a point x1, y1, A is a point x1, y1 on the line, and you take any general point x comma y on the point. Point P is any point. Point P is any point on the straight line. You have it here, point P. And A is the given point on which lies on the line itself. x1, y1. The coordinates x1, comma y1. Now the tan theta and m is equal to, this is the slope is given by y minus y1 by x minus x1. So the equation of the line will be y minus y1 is equal to m into x minus x1. This is the point slope form of the equation of a line. The slope m is undefined or not defined for lines parallel to the y-axis, or those are vertical lines, because tan 90 is not defined, infinity. So that's why. Then the other one, you can say the equation is very simple. X is equal to some constant. That's all. Any equation of the form x is equal to a constant will definitely be parallel to the y-axis. This you should remember very carefully. The slope of a vertical line is, of course, 0, because it is parallel to the x-axis. Equation, now the very important form, the intercept form. The intercepts, two intercepts are given. The y-intercept is b and the x-intercept is a. So we have the equation. This is how it forms. This line intersects both the x and y axis. A along the x-axis and b along the y-axis. Then we move on to the form of the equation is x by a plus y by b equal to 1. That's all. Very simple, very easy to remember. X by the x-intercept, we can remember this way. X by the x-intercept plus y by the y-intercept is equal to 1. Next, we move on to another important form, perpendicular form or the normal form. The normal form is figured out like this. It has two parameters. One is the length of the perpendicular or the normal from the origin, drawn from the origin, or the perpendicular drawn from the origin to the given line, which makes intercepts A and B along the x-axis and y-axis respectively. So the length of the perpendicular is given by the small p, OP, from the origin. The distance, small p. We have taken a point P on the line itself, denoted by x1, comma y1. And this is the equation. Equation is a trigonometric formula which can be given in this form: x cos alpha plus y sin alpha equal to p. We can remember this way. Alpha is the angle between, this is important, angle between the normal, the perpendicular to that line, and the positive direction of the x-axis. Of course, here again there are two cases. One is that P is in the first quadrant, the line P is in the first quadrant, OP, which is an acute angle. Then, if it falls in the second quadrant, then it is negative. That is the obtuse angle, 180 minus alpha, and therefore the tan of that angle will be negative. So it is a negative slope here. You can see the negative slope line itself is negative slope itself, because it is forming like this. The angle is like this. Now, coming to the normal form, it is x cos alpha plus y sin alpha is equal to p, small p, the perpendicular distance. Here the length p is the length of the perpendicular, is always taken to be positive, because it's a length. The length cannot be negative. Alpha is the angle, and gives between the positive direction of the x-axis and the line perpendicular to the given line from the origin. We quickly go through their exercises, can be seen from the textbook resource material of the NIOS. Now we see the general equation of the first degree. General form of the straight line, the very famous equation ax plus by plus c equal to 0. Capital letter A, x plus capital letter B, y plus c equal to 0, where a, b and c are all real numbers. They can take values 0 also. If both a and b are 0, then we have a c. This equation does not exist at all, because c will also be 0, because this equation is satisfied only when c is also 0. When A is 0, but B is not equal to 0, that means it's a line parallel to the, it's a line parallel to the x-axis. It becomes y is equal to B form, y is equal to C form, x equal to A form, and y equal to. So these are nothing but the intercepts form. The equation when both A is not equal to 0 and B is not equal to 0, we get a very famous form, minus A by B. Y is equal to minus A. We divide both sides, each and every term of this general equation by B. Here we are having this equation. We transpose the A to the other side, AX. We get minus AX minus C. And when we divide by B, we will get y is equal to minus AX by minus AX by B into X minus C by B. So what is the actual, this is which form? Y is equal to mx plus C. So minus A by B is the slope of any equation given in the general form. Easily you can find out. So minus A by B is the m, the slope of the line, and minus C by B is the intercept. C can be either positive, negative, or anything. It depends. Then the intercept will be either positive or negative, depending on the sign. Now to convert this general form into various forms, the slope intercept form is given here, minus A by Bx, y equal to minus A by Bx minus C by B, provided B is not equal to 0. Then we have the conversion to intercept form. In intercept form, we slightly do a small modification here. We first bring the C to the right-hand side as negative C. So AX plus BY equal to minus C you will get. Dividing now, in order to make the right-hand side 1, so we have to divide each and every term of this equation by minus C. Whereby the right-hand side becomes 1. And the left-hand side becomes AX by minus C plus BY by minus C. We can also write this as X by minus C by A plus Y by minus C by B. So it is now reduced to the intercept form. Equal to 1 is there on the right-hand side. So X by A, this is small a. The x-intercept minus C by A. We used capital letter C and A, B, C for this purpose only, to distinguish between the small letters A, B, which you are using in the specific forms. So y by, we have a small b. This is the y-intercept is equal to 1, provided A is not equal to 0 and B is also not equal to 0. So this is the converted form of the intercept form of the equation, from the general form to the intercept form. Finally, we convert this perpendicular form or the normal form as, we convert this as this one. It will be converted like cos theta. That is, cos theta from the thing is A by root of A squared plus B squared. And again, sin theta. Sin theta is y by, because the opposite side, the vertical side, the opposite side, y by root of A squared plus B squared. So this is B sin theta. And then this is the actual y sin, sorry, it's y sin theta. X cos theta plus y sin theta is equal to, this is the P, the distance of the perpendicular distance. This is the perpendicular, C by root of A squared plus B squared, which can be got by dividing the both sides by square root of A squared plus B squared. Theta can be obtained from here with appropriate signs, of course. In order to make P positive, always the distance on the right hand side should be positive, because P is only a distance, the length of the perpendicular, so it cannot be negative. So based on that, this plus or minus will come here, minus or plus, based on this, to make always P positive. So we put this in this required form. If you want to make this positive, we choose the proper sign and make it positive here. That's all we do. Either it should be plus a root of a squared plus b squared or minus a root of a squared plus b squared. That's all. So that is the thing. And general equation of the first degree. This first degree means degree 1 in x and y always represents a straight line provided capital A and capital B are not simultaneously 0. So first degree equation, a system of equations, a pair of linear equations in x and y will always represent straight lines, two straight lines. And already in linear equations in 10th standard, we already saw the conditions for intersecting lines, coincident lines, and parallel lines. Based on that, we can say that it's a linear equation. We saw up to now, we saw these equations of straight lines. Now, we can also find the distance of a given point from a given line. It is given by a distance formula here. The distance of a given point, a point is a given line. The equation of the line can be in that form of ax plus by plus c equals 0. We just make use of this formula, ax1 plus by1 plus c. That's all. Forget about all those things. Just you put that x1, y1 points. In the place of x, you put x1, the point x1 and y1. In the place of x and y, plus capital C, of course, as it is. You by the root of a squared plus b squared. We take always the positive sign because we take the modulus, because the distance cannot be negative. So this is the distance small d is equal to ax1 plus by1 plus c by square root of a squared plus b squared. So, and if you take x and y as 0, the origin, it will be c by root of a squared plus b squared, because a and b, x and y are 0, 0, 0. So this equation gets reduced to c by root of a squared plus b squared, the distance, perpendicular distance. Now we see equations of parallel or perpendicular lines. It's very simple. If two lines have to be parallel, we already seen in this 10th standard, we saw that should be, the slopes should be same. That means this, you have a equation a, b, c equal to 0, or a1 we have and b1. So let the slopes minus a by b should be same for both. That's all. Any line parallel to this given line will always have just the ratio of the coefficients should be equal. C1 by C2 need not be equal. That can be anything. But A by A1 is equal to B by B1 is equal to a constant. This is the condition for parallel lines. That means the slope should be equal, because we know that the slope of the line is minus A by B. So if this is the case, then A1 by B1 will be equal to A by B. That's all. That's simple as that. So if this, generally you can remember this way, the coefficients of x and y are the same. Constants are different. They can be evaluated. The straight line perpendicular to the given line is, of course, we already saw, it should have the product of the slope should be negative. So we can come across this relationship, A1 plus B1 is equal to 0. That's all. We now apply this condition, minus A by B. A1 minus A1 by B1 is the slope of this line. Minus A by B is the slope of the second line. They want to be perpendicular. What happens is, these two should be, the sum should be equal to 0, because the negative reciprocal. You just have to take the negative reciprocal has come here. The slope of this line should be equal to the negative reciprocal of the other one, B1 by A. The product B1 and A1 adds up to 0. This is the condition. So very quickly you can find out whether the two lines are parallel or perpendicular. Parallel means the slope should be same. That means minus A, that A by B ratio should be the same for both the lines. So the A by B, A1 by A2, that is, you can verify that by checking the condition. Perpendicular lines, the product of A1 plus B1 is equal to 0. The sum of these products will be 0. Otherwise, it's a negative reciprocal. You can arrive at this result by A1 by B is equal to minus B1 by A. That's all. That's simple as that. So in that case, it will become this. It is actually A1 by B1 is equal to minus B by A. That's all. Anything you can put anyway, you will get this condition only. So finally, here we have come to the equation of a lines passing through it is given by a arbitrary constant, because when you see two lines, they are intersecting lines. Any equation, there may be a number of lines passing through a given h comma k, let us say. When we solve the two equations, we get a point of intersection, and let it be h comma k. Any equation of a line passing, any straight line passing through this point will also have the equation of this form. A1h plus B1k plus C1. This is the equation of the first line. Plus lambda, an arbitrary constant, into A2h plus B2k plus C2 equal to 0. That's all. Actually, h and k represent the coordinates of the x coordinate and y coordinate of the point of intersection of the two lines. Lambda can be evaluated by putting this values of h and k in, and then evaluate lambda first, and then we'll find the equation easily. Now we have come to the end of this chapter. We have seen the various forms of the equation of a straight line, and also the length of the perpendicular, general form, distance. And that's the end of the session.